Hello everyone, so in this video, let us talk about the first four problems from the AtCoder beginner contest 272. So let's start. The first problem is pretty simple. You are given n integers a1 till an and you just have to find out the sum of those. So pretty small constraint as well. You just have to do a for loop, add all the elements given in the array and just return the answer. Pretty much simple. Nothing much to explain here. Second problem is everyone is friends. So there are n people numbered from 1 till n and there are m parties which are held with m parties were held with ki people attending them. Okay, so there are m parties and every party has ki people attending them and the people that are attending them are also given to you. Okay, so there are ki people and the numbers also given to you. Now you just have to find out that determine if every two people attend the same party at least once. That's the somewhat confusing part. I also got confused by understanding this statement, but I'll break down in simple terms as well. Just one more time, read that. Determine it that if every two people, okay, every two people, you have n people, you can choose any two people. So every two people attend the same party at least once. Okay, that's the whole problem. So let us take the input. Let's say there are, as you can see, n. So n total number of people, let's say from 1 till 3 are a different number of people, and there are m parties, let's say like 3 parties. So every party has let's say 2 people. So the first number is k, how many people are attending them. So let's say the first party is attended by 2 people, and the 2 people are the number from you consider the name of them or like whatever number you can give them is 1 and 2. The second party is attended by 2 and 3, and the third party is attended by 1 and 3. Now the overall thing is that let's say there are 3 people. The number of them is 1, 2, and 3. Now, what all possible pairs you can form out of 1, 2, and 3? You can form a pair as 1 and 2. Like one pair is 1 and 2. One pair is, you can say, like 1 and 3. And one pair is 2 and 3. These all are the possible pairs you can form. So, what they're actually trying to say is that there should be at least one party where 1 and 2 should be present. There should be at least one party where 1 and 3 should be present. And there should be at least one party where is 2 and 3 present. There should be at least one party there where every pair you can form should be present. That's the whole thing. Okay, that's the whole thing that you have to find out. So because the constraints are pretty small, as you can see, with the constraints, yep, constraints are very small. So you can just do a brute force way. So what we'll first understand is that you have to first store that for every party who all are coming there. Okay, for every party who all are coming there, and for every party you know that who all are coming there. Now you just try to form every pair out of it. By pair you can just do a nested for loop. Okay, so with 1 I can pair 2, 3. So let's say there are n people. So with 1 I can form pair with 1, 2, 3, 4 and till n. Then from 2 I can form pair with 2, so 3, 4, 5, 6 and till n and so on. So you can just form nested for loop to find out all the different pairs. And for every pair just check out that pair should be present in at least one of the parties. If it is, the answer is okay. Every pair is present in at least one of the parties, the answer is true. Else if any pair, like any pair you find out that is not present in any of the parties, then the answer is false. So it's pretty simple to find out that particular problem. So let us check out the submission for this. I'll load my submissions here. So we have to go over the B problem. So the B problem goes like this, that as we can see that we have created, because it's 100 by 100, so I've created a array, or sorry, a matrix to store that for all the n parties, like there are m parties, what all people are attending them, so that I don't have to just do a for loop. I can just create like you can just a small matrix to count that. So what we have done is that we have iterated over all the m parties, and for all the m parties the k people, so iterated over all the k peoples, k x minus minus, because they are 0th, like we are talking about 0th index, but they are 1 index. You can have also taken 1 index, whatever you want. And then what you have done is that you have just updated that particular value in the matrix. So what I've done is that I have just created a map, and in that map I've marked that okay, for the, let's say, kth party, like any ith party, this and people are attending it. Now what you have done is that now we have done a double nested for loop for every particular possible pair, and you just have to check that for any, like for every possible pair, whether this particular pair is present in any of the parties. There are m parties, so just iterate over all the m parties and just check that whether both of these people I and j, in the j, you can see that these are the parties. So in the z party, whether I is present and j is also present. If both of these are present and it is present, then the present is true, that I have found out that one of the parties, these particular pair is present, and answer is true. Else, if we find out that any of the pair is not present in any of the parties, then answer is no. That we have got an answer that is totally wrong. We have answered false. And if it is every pair is present, the answer is yes. Okay. That's the logic and the code part for the second problem as well. Moving on to the third problem. Third problem is that you are given a sequence A, as you can see from A1 till AN, and it consists of n non-negative integers. Now you just have to determine that whether there's an even number represented as the sum of any two different numbers of A. Okay, you just have an array A. A is pretty large, like 10 to the 5. You cannot do this in a very brute force way. Can you choose out any two numbers from the array A such that their sum is even? And if it exists, what is the maximum such number? So you have to find out the maximum even number and also the even number. What is the maximum possible even number if it is? So what you can first understand is that even numbers can be formed. Like how can even number be formed? Even number can be formed by, because you have taken the sum of two different numbers. So if you're just adding two different numbers, if both of them are even, then you can get even number, or if both of them are odd, then you can get an even number. So you just have to find out first what all odd and even numbers are there inside this whole array. So it's pretty simple. What you can do is that you can first segregate or make two lists, okay, or two vectors or two array, whatever you can say, and just like bifurcate or like divide both of these numbers into two groups, all even numbers and all odd numbers. So you have now two like arrays, small like sub arrays you can say, which only one array consists of all even numbers from the array A, and other array consists of all the odd numbers from the array A. So you have now two arrays. Now just sort out, because you have to find out the maximum value. So you just sort out this array, and now you have three options. Okay, either that, let's say how can I find out the numbers? Either first option is that the even number is not present at all. Okay, the answer is -1. The other option is that I can choose the two maximum even numbers, because that's the very, then they can and add them, and that will give the maximum even number possible. The other case can be I can just add the two maximum odd numbers, and that can also give the maximum odd even number possible. Just want to maximize over all these three conditions and just find the answer. That's it. Nothing much complicated here as well. So let us move on to that particular solution as well. So what we have done is that we have created two vectors of even odd, just segregated all the numbers from over this whole array that we have into even or odd, depending upon whether it is even or odd. And sort out both the even and odd. This is R begin, which means that this I have sorted in a decreasing order. The starting with the starting numbers with the maximum. Now I have those values. Now I've initialized the answer with -1, that I do not know that whether it is present or not. It is -1. Now, because I want to form a pair, I have to check that the even array that I have formed by taking all the even numbers from the array A, that should be at least 2 length, because then only I can take the two numbers from that to form a pair, because two even numbers are required. So if the even array, sorry, is of length greater than or equal to 2, which means that it has at least two elements, I want to maximize my answer with taking the first two even values. That is the maximum possible among all the even values, because it is from descending order. So taking the first two even values, or the other case can be like also you can take the first two values of the odd array if its length greater than or equal to 2. That is also we have taken the two maximum odd values. So I just have to maximize, like if either of these conditions, let's say even is also less than 1 and odd is also less than 1, okay, or maybe there is only one odd and all and one even. So in those scenarios, this condition will not meet and the answer is always -1. Other cases that if it is possible, then the answer will be maximized over this condition and this maximum answer will be printed out. And that's the overall third problem for this particular contest. The fourth problem is root m leaper. So as you can see that there is a grid of n cross n square. You can just assume that there's a grid of n cross n square that is given to you like this. You can just assume that. Now what we'll denote is that we can denote by like every block in that is denoted by ij, which is like you can just say that ith row and jth column. Now what we'll eventually do is that we start from the 1, 1. We started from the very top left block, and then what we'll do is that we will do this particular operation a number of times. We actually have to reach all, like we just have to find out actually, okay, just go to the prompt statement. What we'll do is that let ij be the square, the piece I am currently on, and I want to go to, let's say, any other piece. Then the distance, like I can only go to other blocks when the distance between my block and the other block should be is equal, like exactly equal to under root of m. What it eventually means is that I am on, let's say, I comma j. I can go to any other block such that the distance between my block and that block I want to go to should be equal to exactly under root of m. Now the distance is calculated by this particular formula which we have generally used to find out distance between two blocks in a grid. Okay, now the shortest distance between two blocks in a grid, and that the basic thing that we have to remember it. I'll show you in example also, don't worry. But the overall scenario here is that we are given that I stand on 1 comma 1. I just have to tell that what is the minimum number of steps required to get to all the blocks in this whole array, or like sorry, in the whole matrix. If it is not possible to reach that particular, like let's say block, then the answer is -1 for that. Else, if I can reach that, then you just have to return the minimum number of operation required to reach to every other block. Okay, so let's show you with the example. Let's say that we have a 3 cross 3 grid, that is this 3 cross 3, and my m is equal to 1, which means that I can go to one direction in any of the direction. What I mean by this is like this formula just tells you that the distance between my block and the block you want to go to, the number of blocks, the total number of blocks you will go should be equal to m. Okay, so I'll tell you with the example only. Let's say I have a 3 cross 3 grid. I'm on this, that is 1 comma 1. So m is equal to 1, which means that I can go to any direction 1 point. Okay, so I can go to this. So the number of steps. So this is one step. So I can do this number of steps. So m equal to 1. So this is one step. So I can go to this block in one step. I can go to this block in one step. So this is 1 and 1. Now if I want to reach this block, I have to go to one step here and one step here. So it is 2 blocks away. To reach to this block also one step, one step. So this is 2, this is 2, this is 2. Now to reach this block, I have to go one step here, one step here, one step here. So this is 3 blocks. So 3 steps. So what I eventually do is that from any block, I can go to this number of steps, m equal to 1. So this m is also given to you, how many steps I can go to, and n is also given to you. And you just have to tell that what is the number of steps required to reach to every possible block in the grid. So it's a 10 cross 10 grid. So 10 cross 10 is output for this. Now, how can you solve around this problem? The thing is that first you have to find out that from a particular grid point, what all box or like how many directions I can go to, like which all possible movements I can go to. And then I have to find out the shortest distance over a grid, and the shortest distance over a grid can be easily find out by BFS. Okay, so I will just have to do BFS. It's very striking observation which you can directly do, that you just have to do BFS over this whole array by just finding out that what all particular like blocks I can go to. That's the overall thing that we have to understand. Now, how can we do that? First of all, the thing is that I have to first understand that what all like options I have to move around. The thing is that I have under root of m. Okay. Also, I'm starting from 1 comma 1. Okay. You could have also stated as 0 comma 0 as well. Why? Because like you just shift all the grid, because it's an infinite grid. Okay, you can just assume that it's very big grid. If I just start from 0 comma 1, like 0 comma 0 or 1 comma 1, it doesn't matter, because I'm just understanding like how many distance I can move. That is this m. Okay, doesn't matter from where I start because it is 0 comma 0. Now, because I want to also do this from 0 comma 0, because the grid I want to start with is also indexing, so that's why 0 comma 0 also. You can also start from 1 comma 1, whatever you want, but that's why you have to do some adjustment also. But the thing is overall here is that what I'll do is that I'll start from 0 comma 0. Now what eventually I'll do is that first understand that okay, let's take an example of m equal to 5. Now what all blocks I can go to. Okay, the thing is that let's say I am on any block, let's say here. Let's say I'm here. Or let's say n m equal to 3. So I can go to 3 blocks, which I mean is, what I mean by this is, let's say I can go 2 blocks on the right hand side and 1 block on the top. Because see, the distance between this block and this block, if I find out, is equal to the distance between the x coordinate and the y coordinate. Okay, and the distance between them turns out to be like, you just add them. It's just a simple formula we have learned about that. So it turns out to be 3 only. What it eventually means is that I can go to 3 blocks from the particular direction I am on. Okay, so I can go to like this 1 2 3. Okay, okay, so okay, 1 2 3 is like, which means that I can land to this block. This particular movement is not allowed. I can have done like this. So I can do only one type of switch. Okay, one switch. What I mean is like I can go to all the way from 1 coordinate to 1, and then like say I would go to 3 steps. So like 1 and 1 step like this, and then 2 steps, or maybe 2 steps like this and 1 step. Okay, so all of these particular blocks I can go to. So I have different possible combinations I can go to. So from this I can go to this. So what I can do is that I can first find out all these particular combinations I can go to, and then I will do a BFS. Let's say I can go from this to this point in one step. That is m operation. That is, if I do this particular jump, that is m the times I've like this is the distance between one block and another block, I can go in m equal distance, then that is one of the operations. Then from that I can again go to m steps. So let's say I can go to like this, or maybe I can go to, let's say, like this, okay, whatever you want, okay, or maybe one step and two steps and like this, or whatever you want. So from every block I can go to and do a BFS, understanding that I should not be traveling over the same block again, and also it should not be out of bound. That's what the overall idea is. I'll just move on to the code side, it will become more clear to you, but that's the overall thing that we will be using out. So what we have done is, we have first created an vector A, okay, that will be storing out a final answer that will be printing out. This is the shifts vector that will be storing us that from a particular block I am on, what all particular different blocks I can go to. So what I'll do is that I will just do an iteration from -n to n, okay, and also from -n to n. So what it does is that I just have to check that, because see, let's say if I'm on any ith block, okay, the distance between I want to from like whatever point I'm on and I want to go to, the what you can see is that if, so let's say the distance I into I whole square plus j into j whole square, because see, oh sorry, this is I into not I into I into I, this is I into like I square plus j square, sorry, so I square plus j square, because see, this is the distance I want to travel to, okay. What it eventually means is that I want to take this amount of distance. Now what we'll do is that from 0 comma 0, okay, if I want to go to any distance, like this is the, so whenever I go to any point, let's say, I can again call it 0 comma 0 and again go to this distances, like, so what I'm trying to do is form out all the pairs from which, like if I'm on any pair, like any I comma j, what all different configurations of block I can go to. So what I've because there are only finite number of blocks is from any I comma j, I have just done an I from -1 to n and from j -1 to n. I have calculated out that I into I in j comma j is equal to m, because like the under root part, this is under root here and under root here, they are just cancel out. So if this turns out to m, I have pushed this particular pair in shifts. This will eventually store all the particular pairs from any I comma j I am on, what all particular directions or particular movements I can go to. These are all shifts I can do. Then I've just do a BFS. What I've done is that I've started from 0 comma 0, so initialize this particular value with 0, and then push that particular value or coordinate in the, you can say, the cube. Then I will just do you can say keep on doing a value until this cube becomes empty to pop out the first element. From that particular first element, now I have to use this shift array, because from that particular point I can go to what all directions. I can use out all the particular configuration from the shift array that I've pushed out and iterate over, do a for loop over all the particular configurations from that shift array over in all the directions. Okay, that's what we have done. Okay, and then I just have to ensure that it should be inbound. It should be inbound. That is, this condition is covered, and that is not already traveled. If it is not traveled, then if it is gone out of bound, or if it is already traveled, then you just continue out. Okay, if it is not traveled or it is inbound, then what we'll do, I will go to that particular point, and the number of steps I will take is the number of steps I am on, the number of steps it takes to get to the particular point I am on, plus 1. Okay, because I'm going to the next block by doing this under root m distance operation. So the number of operations I have required to go to my particular block plus 1 is the number of blocks steps I go to that particular block. And then again, because I have reached that particular block, I will again push that particular block that I've reached in the queue, so that it will keep on doing this BFS until I've iterated all the particular blocks. And if it is not, then because we initialize with -1, it will stop. Like all the other blocks that are unreachable will be initialized with -1, and that will not be stopped. And the end, we have just done all the BFS and just written the total number of steps. Just print out the whole like matrix, you can just say. That's it. That's the logic and the code part for all the 4 problems. All the code will be in the description of this particular video. I will see you in the next one, like coding, and bye.